Let's start with this equation today. I believe the first time you saw this equation in this class was the second day of school. Remember back to then? Yeah? You've slept since then? Okay, fair. Let's see if we can remember anything about this. First of all, let's talk about what the graph looks like. Well, if x is 0, what is y? 0, right? If x is 1, what is y? 1. Square root of 1 is 1, right? If x is 4, what is y? What did I choose 4? Because I know the square root of 4, don't I? If x is 4, y is 2, isn't it? What else am I going to choose, you think?
6.
You know the square root of 6?
No.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 3, right? So the parent function looks like this. Agree or disagree? Okay. What's the domain of this function? Remember what's domain? X is? X is greater than or equal to 0, right? Because 0 is included in the domain and the x values that are allowed to happen. What about negative? We didn't talk about any negatives. What if x is negative 1? What's y? What's the square root of negative 1? I, imaginary, so that's not a real number, is it? So we can't have any values over here, can we? Okay. So this is how we wrote domain when we talked about inequality notation, right? Then we had set builder notation, and it looked like this, right? And then we had interval notation. What did interval notation look like?
Wasn't it your okay.
0 to infinity. Remember that? Everybody okay with that so far?
So you can use any of them?
Yeah, any of those are the domain. I'll either make it clear which one I want or it doesn't matter. Okay? What about the range? What's the range of this function? X is greater than or equal to 0. Wait, I already messed up. Good. So y such that y is greater than or equal to 0. Or interval notation. Which one is right? Is it infinity to 0 or 0 to infinity? Don't we always do least to greatest? What's least? 0 or infinity? 0, right? So 0 to infinity. Everybody okay with that? Okay. What about this one? This is a cube root function. So if x is 0, what is y? 0. If x is 1, what is y? 1. If x is 8, what is y? Why did I choose 8? It's something I knew the cube root of, right? So it looks like that. Does anyone want to argue with her? The 3 is cube root, remember? What times what times what equals that number? So that's why I chose a 1 and an 8, because I know the cube root of those two numbers. What about the cube root of negative 1? What times what equals negative 1? Guys, what times what equals negative 1? Does 1 times 1 times 1 equals negative 1? No, negative 1 does, though. If x is negative 1, y is negative 1. What about negative 8 then? 1, 2, 3, 4, 5, 6, 7, 8. So doesn't this one look like this? Yeah? Okay. What is its domain? All real numbers. So negative to positive infinity? What about its domain, its range? All real? Any questions about that? Got it? Then let's talk specifically about some transformations that deal with square root and cube root functions. Okay? Now, earlier when I was like, let's do transformations, they were like, oh, we already know this. Well, that should be a nice easy 100 then, shouldn't it? Let's look at it in a positive way, yes? All right, let's start here. Y equals the square root of x plus 2. What does its graph look like? It's up 2. And then, is it parent function shape? Does it have any multipliers with it? No, so it's just parent function shape, right? So here was the parent function, and then there's the new function up 2. What are the words that go along with this? How does it move compared to its parent? Vertical. Up 2. What's the most important letter in that sentence? F. You got to remember your F's. What's the domain of this new function if I've moved it up 2? How far left does it go? Really? Okay, 0. How far right does it go? To infinity? But it includes the 0 and doesn't include the infinity, right? So I could say x is greater than or equal to 0. What about the range? How far down does it go? Ooh, that's different than a parent, isn't it? Starts at 2 and goes to infinity. So y is greater than or equal to 2. What about that one? So if this is the parent function, then this one has moved down 3. Like that, right? And so our words would be down 3. What is its domain? How far left does it go? 0. How far right? Infinity. So x is greater than or equal to 0. What about its range? -3 to infinity? Yeah, that's right, because see, it goes all the way down to -3 and then it goes up all the way. So y is greater than or equal to what? -3. Okay, so far? What about this one? Is this a stretch and a shrink? That would be multiplying, right? Would this one still adding or subtracting? So we'll go 4 to the right. Why is it to the right and not to the left when it says -4? So that's the parent, and that's the new one, right? So this is a what kind of movement? How about right 4? Would that be okay? Okay. What is its domain? It's not 0? Oh. 4 to infinity. So x is greater than or equal to 4. What about its range? Zero. So y is greater than or equal to 0. See, it goes down all the way to 0, right? And then up all the way. Left 5. So there's my parent. And there's in the new graph. I didn't draw that very well. You guys can imagine better, right?
Okay, so it's to the left because it says positive plus 5 and the opposite. When we grab it.
Yes. It's different than what you think. Horizontal things are different than what you think. Okay? You think it's going to go right, but it doesn't. It goes different. Left. Somebody who hasn't answered yet. What's the domain? -5 to infinity. See, look, how far to the left does it go? -5. How far to the right does it go? All the way. So x is greater than or equal to -5. What about the range? 0 to infinity. So y is greater than or equal to 0. Do you notice that when we have a vertical change, a vertical shift in this case, that the domain doesn't change from the parent? But when we had a horizontal shift, we moved it left or right, the range didn't change compared to the parent? You okay with that? Just making some general observations. Okay? What about this? So if this is the parent, where's it going? Reflection over what? X-axis. This is the x-axis. If it's reflecting over that axis, it's down here, right? Okay. What's the domain then? How far left does it go? 0. So 0 to infinity. So x is greater than or equal to 0. What about the range? Okay, so we talked about this already, right? We always do our least to greatest, so we can't say 0 to -infinity. Very good. -infinity to 0. But what goes where? Like what symbol goes where? Parenthesis goes here. Yeah, bracket goes here. How do we write it in inequality notation? Very good. Y is less than or equal to 0. What's the next example look like? Can you predict for me?
Negative y. Oh, negative x inside.
The square root of -x. If this is my parent, where does this one go? That's my y-axis, so it goes this way, right? Okay. What are my words?
Reflection of the y.
Okay, so what's my domain? Negative infinity to 0. Right? So when it goes all the way to the left, which means it goes all the way to negative infinity, as in it's coming right, it stops at 0, doesn't it? So x is less than or equal to 0. And what about the range? Yeah. So y is greater than or equal to 0. You okay so far? What? Sorry, I'm a fast writer. Because I say how far down does it go? It stops right there at 0. How far up does it go? All the way. Nope. Because it's on the positive side of the axis. Okay? Do we have more to do? Or is that it? We do have homework, but would you rather see all of the instruction before the homework? Okay. So what have we not talked about? Somebody mentioned it a second ago. Wait, what'd you say? No. We talked about adding on the outside, subtracting on the outside, adding on the inside, subtracting on the inside. We have to multiply, right? What happens when we multiply? A stretch or a shrink, right? That changes the shape compared to the parent. So let's start here. First of all, where is this number? It's on the outside. If it's on the outside, what kind of change is it causing? A vertical change, right? So this is a vertical what? Why is it a stretch and not a shrink or compression? Because it's larger than 1. 6 is larger than 1, isn't it? So if this is the parent, a vertical stretch means I hold on to some particular point, in this case the beginning point, that 0, 0, and I vertically stretch it. So I grab it this way and pull it up. Grab it here, pull it up. If I'm pulling it up, it's going to go like that. Does that make sense? Yes. What about its domain? Zero to infinity. So x is greater than or equal to 0. What about its range? 0 to infinity. So y is greater than or equal to 0. I thought you told me that that's what the parent function domain and range was. It's the same because it doesn't move around, right? All it does is stretch higher. Well, we already know it's going to infinity higher, don't we? Okay. It starts in the same place, so its beginning point, domain and range isn't going to change, is it? It's still going all the way up, and it's still going all the way right, so its ending point for domain and range isn't going to change. What about this one? It is. If this is the parent, what happens? It's a vertical shrink by a factor of what? By 1/7. We'll talk about that in a minute. We're not there yet. So vertical shrink means I hold on to this point and shrink it, like I squash it down, right? Compression is the other word we sometimes use, and that might make more sense if I'm going like this, if I'm compressing it. That means it's going to get smaller by a factor of 1/7. Yeah? Okay. So what is its new domain? 0 to infinity, or x is greater than 0, greater than or equal to, excuse me. What about the range? 0 to infinity. So that domain and range didn't change either? Dang it. Why? No, something I want you to notice. If all you're doing to it is multiplying, like changing the shape, it's still starting and well, I say ending. There's not an ending if it's going to infinity, but it's still starting and stuff at the same place, so the domain and range is not going to change, is it? Here's the parent. If it's inside, it's a horizontal change, right? So is this a shrink or a stretch? Why is it a stretch? It's inside, so it's different than what you think. You think it's supposed to be a shrink because it's between 0 and 1, but since it's inside, it's the other one.
If it's a fraction, is it always going to stretch?
No?
Oh, okay. So don't do that way.
What's this a stretch by a factor of? 8. How is... yes. Absolutely.
So how come it wasn't included in 170 because it was on the outside?
Because it's on the outside.
Wait, so how would you graph it?
We haven't gotten there yet. That's a good question. Let's talk about it. If I'm horizontally stretching it, I'm holding onto this place and horizontally stretching it, so I'm pulling it this way. So what's going to happen to it?
It's going to be the same one.
Yep. So won't its domain and range be the same as the one above it? Which is still the same as the parent function because I haven't shifted it anywhere. Right? Any questions? Am I writing slow enough now? I tried to slow down. What's the last example going to be? What's my last example? Square root of 9x. We've already done the negative inside. So if this is my parent and I horizontally shrink it, what's going to happen to all that? Like that, right? By a factor of what?
3, 2, 6,
1 over 9. Domain? Questions? So, would you stop, please? So I've done a whole bunch of examples for you of square roots. Yes? Do I need to go back and do every single example again for cube roots for you? Like every single one of these, cube root of x plus 2, cube root of x minus 3, cube root of x minus 4 on the inside, cube root of x plus 5 on the inside, and so on? Will the words change? If this was a cube root, would it still be a horizontal shift left 5? The graph would change, right? Because it would be not this, but this. What would be true about the domain and range if it was a cube root? Every single problem would be infinity to infinity? Every single problem. If I took this cube root and shifted it up 2, would it still be infinity to infinity? If I shifted it down 3, would it be infinity to infinity? If I shifted it right 4, left 5, what if I flipped it over the x-axis? Still infinities? What if I flipped it over the y-axis? Still infinities? Oh my goodness. What am I saying by that? I don't have to redo all the examples, because first of all, the only thing that would change if I made this 6 cube root of x is the graph. It's still going to be a vertical stretch by a factor of 6. And what would the domain and range be if I'm doing a cube root of 6? Sorry, 6 times the cube root of x. Domain and range are going to be what? Infinity to infinity. Okay? Yes or no? Like this, but it would be stretched, so it would be like up here, down here. So same kind of rules as that was applied to here, it just would look different on the graph. But the words, the description of the change from the parent function would be exactly the same. Okay? Can you have more than one of these things happen at a time? Are you okay with that? So, but if I shifted it down 3 and right 4, would that change the domain and range compared to the parent? Yes. In fact, it would change both of them, right? All these ones that we've done so far had at least one pretty much that was the same as the parent, right? If you start having multiple ones of these changes, you're going to have multiple changes compared to the parent, won't you? If I gave you this, the words, could you tell me the equation? We didn't do any of those. I gave you the equation on all these and you told me the description, right? But if I gave you the description, could you tell me the equation? Good. You're going to need to. Okay. If I gave you the graph, could you write the equation? Yes. You can go back and forth and stuff between these things, right? I can do all of them. I don't know what you need me to do. What's the equation of that graph? Well, what does it start off with? Y equals, okay, got that. Is this a square root function or a cube root function? Cube root, so I'd start off with a cube root. It went up 3. Wait, this point only went up 2. Which point do I look at? Wouldn't I look at that point? The one in the middle, right in there in the middle? That's going to be the point. Now, first of all, every point is moving up 3 or left 3 or down 3 or something like that, right? But the one we want to look at to find the equation is that middle point. Right in the middle, right in the change of direction. So this point right here is what I want to look at. It moved right 4. In the equation, what makes it move right 4? X minus 4 all underneath the radical, right? And then plus 3. Where does that go? Is it parent function shape? Did I go over 1 up 1 and over 1 down 1? Then that's parent function shape. It hasn't changed shape. If I went over 1 up 2, you would know that was changing shape by a factor of what? 2. So I would have a 2 up here. If it went this way, you would know I would need a negative right here, right? Does that help? Okay, so that's what I'm talking about. If I give you a graph, can you give me the equation? What if I said vertical shift, let's see, vertical shift is up or down, so how about down 4 reflects over the y-axis. Tell me the equation And I'll say, here, the f of x is the square root of x. Tell me what g of x is with that kind of shifts and stuff.
Okay, wait, so it's saying that the f, that's our parent.
That's what you start with.
Start with, okay.
So write g for me. Write the change. So square root of x minus 4. Is that on the inside or the outside? Outside because it's vertical.
If it was horizontal, it'd be inside?
Yes? Yes, it would. And that's it.
So the y-axis is going to be a negative?
The negative will be on the inside right here if it shifts over the... Hold on a second. This says y-axis. So we'll pretend that was part of the square root sign the whole time. And the negative goes in there. Is that what you mean? You want me to write it cleaner for you?
X-axis is the outside?
It would be like that. There, that's a lot nicer. X-axis would be on the outside, yes. Okay? Does that make sense? Any questions?